Is there any questions that you would like to start going through, either on the Module 1 and 2 objective review or the 3 and 4? You can either say it through the mic or, okay, number 1 on which review? Okay. All right. So just, let's see. Let me see. Some people are not responding, so I can't tell if they're hearing me or not. But all right, we're gonna. So it looks like we'll do number 9 on review 1 and 2. And then somebody said number 1, but I'm not sure which review you wanted to look at for that. So number 9 on 3 and 4. It's a graphing problem, so I was hoping I could write right on here, but for some reason it is not playing nice today. So we're going to go ahead and start in this. So when we're graphing a line like number 9, there's a couple of different ways that you're able to graph that. So we're trying to graph y equals 1/3 x plus 1. And so you can do a couple of different things. When you have it in this form, you could make a table of values, picking some x's and figuring out what the y's are. And so usually we like to choose some smaller numbers that are easier to pick. However, since we have a fraction here, we want to kind of pick these numbers a little bit smartly, I guess. So we'd want to actually pick things that are multiples of 3. That way we don't end up with any fractions for our y. So I'm going to choose 0, 3, and -3 for the x's that I choose. So when I do that and I put 0 in place of x, right, I get 1/3 times 0 is 0, plus 1 is 1. Then when I put 3 in, and I'll write this down over here, so we have y equals 1/3 times 3, and then we'll add 1 after that. But you'll see we pick these numbers in such a way that the 3's will actually divide out, right, because there's really a 1 underneath there. And so we're just left with 1 plus 1, which will give us 2. All right, and we're finding ordered pairs here, right? So we've got 0, 1, and we've got now 3, 2. And then we'll do the same thing for -3. So if we put -3 in place of x, we'll have 1/3 times -3 over 1 plus 1. So we'll reduce here first, right? So we end up with -1 plus 1, which gives us 0. So there's 3 points, and we should be able to get a pretty good idea of what is going on there. So let me try and graph this here. So over 0 up 1 would be here, over 3 up 2 would be here, and then over -3 up 0 would be here. So my line looks something a little bit like this. Okay. And then the other way that you may have talked about in your classes to graph this, where you don't need to use points, you actually start with the Y-intercept, right? So that is right here. And then from there, you'll take and you'll apply the slope to it. So remember, our slope is rise over run, so it's saying we're going to move up 1 and to the right 3. And you see that puts us right there at that point. Or we could go down 1 and to the left 3, because -1 over -3 is still just 1/3. All right. So so that's kind of a, just making sure you see that it's still going to stay on the same line there. Okay. That's a good one to look at for sure. All right. So it looks like there's been some requests for some questions off of Module 4. So let's take a look at maybe some of those. Were there some specific ones that you wanted to look at in Module 4? Let's just start looking at a few of these. So we'll just start, maybe we'll do number 34, and it's solving the system by substitution. So if we can, we'll talk about how to solve systems of equations using substitution method as well as the elimination method, because it'll be good to know both ways on this. Okay, so number 34, notice that our equations are not in standard form, and that standard form is like this: ax plus by equals c. And so if we're going to be doing something by elimination, then we need to make sure that it's in this form. But since we're doing this one by substitution, it's actually kind of nice that we have one of the variables by itself already. So our equations say this: -5x minus 6y equals 39, and the other one is x equals 2y plus 5. And so with the substitution method, remember, we know that x is this. All right, so I'm going to circle this part. And so that means that we're going to put that 2y plus 5 in place of x into the other equation. And when I do that, I get -5 times 2y plus 5 minus 6y equals 39. And now you'll notice we only have y's in our equation, where before we had an x and a y, so we couldn't solve for those until we have the same variable there. All right? So now let's go ahead and apply that through. So we've got -10y minus 25 minus 6y equals 39. We'll get our y's together, so that gives us -16y minus 25 equals 39. And then we're still trying to get y by itself, so let's add that 25 over. All right, so it looks like we get -16y equals 64. And so if we solve that for y, what do we end up with there? Okay, looks like y would equal negative oops. Is that -4? Is that what you guys are coming up with? Sorry, my pen is kind of being weird here. All right, so we found part of our answer. Remember that we have two different parts of the answer. We're trying to find the point in which these two lines are crossing each other. So we found that y is -4. So I'm going to put it here because remember our ordered pair is always x and then y. But now I still need to go through and solve for x. And so I can take my answer that I got, right, that y equals -4, and I'm going to put it, I can put it back into either equation, but I'm going to choose to put it here because it looks like it's going to be easier for me to figure out what x is. So that would be x equals 2 times -4 plus 5. So that gives me -8 plus 5, which is -3. So the point in which these two lines are crossing each other is at -3, -4. Now, you probably don't need to write it as an ordered pair unless it says to on the exam, but if not, you can just keep it in these forms and make sure that it's clear, right, that what your x is and what your y is. Okay, awesome. All right, did anybody find another one that they'd like to go through next? Please speak up on the chat. I want this to be a review that is going to be helpful to you. You can either speak through the mic or through the chat. Okay, having a request for number 19. Okay, and on the same review, number 19. Is that correct? All right, so number 19, correct me if this isn't the one you wanted. So it says, find the slope and y-intercept for a line, or of the line for the equation that's given there. So since this is in slope-intercept form, it's nice to be, it's pretty easy to pick out what the slope and y-intercept are. All right, so when I'm looking at number 19, it says y equals 1/9 x plus 7. So remember that you've talked about an equation a lot in class, which is y equals mx plus b. And since it's in that form where y is by itself, just like this equation is down here, then we can see that the number in front of our x is going to be our slope, because that's what the m stands for, right? And then the b is our y-intercept. Right, so that means in this problem that 7 is our y-intercept. But in my classes, I ask them to write their y-intercept as a point because I want to make sure that they see that it is an ordered pair, right? And so that ordered pair, y-intercept is always going to be 0, comma, some number, and that number in this case is our 7. So our slope is 1/9, our y-intercept is 7, but specifically 0, comma 7. But let's take a look at number 20 also, because I find that on the test, oftentimes students see the equation in this form and then they think that they can just pull the slope and y-intercept out just like it is, meaning they say, oh, the slope must be -6 and -32 is my y-intercept. However, our equation isn't in this form, so we first need to solve for y and get y by itself in order to tell what the slope and the y-intercept are. Okay, so let's do that. So if we're solving this for y, I'm going to start by adding my 6x over. and that will give me 8y equals 6x minus 32. And then y is still not by itself. We need to divide everything by 8. And if I reduce the fraction, right, 6/8 will reduce to 3/4. So I've got 3/4 x. And then negative 32 divided by 8 is negative 4. Right? So again, we can see now that it's in this form, the number in front of our x is our slope, and the negative 4 is our y-intercept. Okay. Or, remember, we could write that as 0, negative 4. Is that making sense? Okay. Like I said, this one kind of shows up on tests more often, it seems like number 20, and so make sure you get that into that slope-intercept form first. Okay? All right, what other questions would you like me to help you with tonight? I think question 12, did we do that one yet? Okay, yeah, this is a good one to look at. So review 3, question 12 is another graphing question. And I want to take a look at this and maybe just look at both 11 and 12 at the same time so that we can kind of compare and contrast because they're similar in some ways and different in others. So be able to look at how that is. So number 11 asks to graph y equals 4. And so on this, people go, well, how is that a line? It doesn't seem like a line. It's not in that same y equals mx plus b form that we've seen before, and so it looks weird. So one way that you can help yourself to remember on the test how to graph this is keep in mind an XY chart. So on this, it's not telling us anything about our x, but we do know that no matter what our x is, our y has to be 4. So that means that we're going to, we could put any numbers in here like -1, 0, and 1, and all of our y's are 4 because that's what it told us here, right? So now we're going to say, okay, let's get these points on here. So over -1 up 4 is here, and over 0, whoops, put it in the wrong place. Over 0 up 4 is here, and over +1 up 4 is here. And so I can see that my line is a horizontal line. So whenever we have a y equals some number, it is always going to give us a horizontal line at whatever the number is that it tells us. So, a quick way is to think about it is, okay, on the y-axis, I'm going to go up 4, and I'll draw a horizontal line there. Right? Similarly, for number 12, right, now we have x equals -2. So again, we look at that and go, how am I supposed to graph that? That looks so weird, right? And so when we're doing this, ooh, what happened there? So when we're doing this, again, we have, the same kind of idea where we're thinking, okay, if I was thinking of a little XY chart here, all I know is that -2, my x is always going to be -2, no matter what. So then my y could be any sort of numbers. I'm just picking ones that are smaller, closer in here. So over -2, all right, down 1 would be here. Over -2, down 0 is there, and over -2, up 1 would be here. So now we can see, oh yeah, this is going to be a vertical line at -2. So whenever it's an x equals some number, we're going to always have a vertical line. All right, but drawing these points sometimes here to remind you, especially in a testing situation, if you're like, oh no, which one's which one's horizontal, which one's vertical. All right, this can really help clarify that for you. All right. Let's see, somebody said this is different from the 12 I see. Did you mean 12 on objective 1 and 2, perhaps? Let me see what number 12 is here. All right, so this is what I am seeing. Module 3 review? Huh. I was just on the Module 3. This is number 12 on the other one. Is that the one you'd like to work through? Darn it. Can you tell me what type of problem it is, and we can find one like it? Yeah, so somebody said these are actually like PDF documents that your instructor usually either emails to you or sometimes they put them on Canvas, but they're not like an online homework. So if you're looking at the Module 3 review that you do with the like with the homework type problems, those are not the ones that I was going to work through, but I'm sure willing to work through one that's similar to it if you can find one and tell me what it is about, and I'd be more than happy to do that. Okay. Thank you. I think it was Lindsay that was saying that. That's probably what's happening. Okay, so let's try this one then. So he said, let's find the line that goes through 8/9, and then it gives, it's probably the slope is 8/9 and through a point. So let's find one like that on here so we can kind of stay with that. So here's kind of one that's similar to that. However, this one's a little bit easier because if you'll notice, the point that's given to us is the y-intercept, and so we're just given the slope and the y-intercept. But oftentimes they're not going to give us that y-intercept. But let's work through number 26 because it's kind of similar to that, except you have to actually find the slope, and that's usually something that they'll want you to know how to do on the test. It kind of, two birds with one stone kind of a thing. So we're trying to write an equation. Write an equation of a line that goes through the points -4, 7 and 3, -14. All right, so when we recall, our equation of a line is y equals mx plus b. So we need to know what our slope is, and we need to know what our y-intercept is. And once we know those two things, we can write the equation of a line. All right, so we're given 2 points, and we can find the slope if we know any 2 points. So I'm just going to label these down here as this is x1, y1, and x2, y2. All right, and then this is a formula that you need to make sure that you have memorized for the test, and that's the slope formula, all right, which is y2 minus y1 over x2 minus x1. All right, so make sure you have this slope-intercept form memorized as well as this slope formula, right? How to find that. So in this case here, when we're trying to find the slope, all right, we'll have m equals, and I'm going to do negative 14, all right, because that's my y2, minus my y1, so minus 7, divided by my x2, right, which is 3, minus my x1, which is negative 4. And be careful when you have these negatives because we're minusing a negative 4, which really, right, when we're minusing a negative, we're really adding. And so that's one thing that you've got to be careful of there, right? And so on the top, negative 14 minus 7 is negative 21. And then on the bottom, 3 plus 4 is 7. And so that's going to reduce to negative 3, or you can think of it as negative 3 over 1 when you're thinking about rise over run. Okay, but there is my slope. Right? And so now we need to still find the y-intercept. And there's a couple of different ways that your teacher may have taught you to do this. So let me show you one way and then speak up if you want me to show you the other way, if this way isn't looking familiar to you. Okay? So if we go back to this equation, right, this y equals mx plus b, then I'm going to fill in some of the things that I already know. So I know a point, right? I actually know 2 points, but I only need one in this case. So if I know a point, right, and I have this is my x, this negative 4 is my x, and 7 is my y, I'm going to put those in place of my x and y that are down here, right? So I have, in place of y, I'm going to put 7. And then I know my slope is negative 3, so I'm going to go ahead and put that one in. And then I also know an x-coordinate, make sure you pick the same one that was with the y that we chose, right, is negative 4, so times negative 4. And then plus b, so this is the last thing, and this is what I don't know, and that's what I need to find is my y-intercept. So if I, solve this now for b, right, I'll have 7 equals negative 3 times 4 is 12 plus b, and then minus the 12 over will give me b is negative 5. So now I know my y-intercept, right, and I know my slope, and now I can use that to write my equation of a line. So again, coming back to this, y equals mx plus b, right? When I'm writing an equation of a line, I need to have my x and y in there because remember, my x and y is going to change all along that line. So I'll end up with y equals, in place of my slope, I'll put negative 3, and then in place of my y-intercept, I'll put negative 5. And that is my equation of a line. Did that make sense? Or did you guys want to see it a different way? Because some of your teachers may have taught you using something called point slope formula. Okay? And that's fine. So if you're used to that way, then that's one other formula that you need to make sure that you have memorized for the test, right? So I said you need to have this one memorized. I'll put these in orange, right? You also need to have the slope formula memorized. And if you do this the other way, then you also need to have the point slope formula memorized, which says this. It says y minus y1 equals m times x minus x1. Does that look more familiar to you, Jocelyn? Because she said she wanted to look at it a different way. So let's just do this one really quick. Again, we know our slope, right? We found our slope, and we have our x1 and our y1 that we're going to put in those places. Okay? So we have y minus 7 equals, our slope, our m, is negative 3 times x minus a negative 4. All right, and be careful with that. Minusing a negative 4 is really adding 4. All right? All right, and so then when I still need to get this into this y equals mx plus b form, that's what it says in the directions. So let's distribute that negative 4 through. So I've got y minus 7 equals negative 3x minus 12. And we're almost done here. We just need to add that 7 over now. And when I do that, I get the same thing that I got above as y equals negative 3x minus 5. All right, so either way that you feel more comfortable getting to that is perfectly fine. I always tell my students, use what works best for your brain. So if the slope-intercept form is better for you that we did up here, or if the point-slope formula is better, choose that. So I'll put this so this is what you need to have memorized if you're going to do it that way. Okay, none of those things will be given to you on the test, so just so you know what things you need to memorize. Okay, David said, and please speak up everyone if you want to look at some different problems. You can write it in the chat or you can say it through your mic if you'd like. But he wants to look at something with graphing an inequality, graphing a linear inequality. So let's look at, since this is on our review here, number 13. All right. So for number 13, it says we're going to graph 2x plus y is less than or equal to 2. So again, we talked about before that you could either make a table of values to help get this graphed, or you can get it into the slope-intercept form and graph it from there. So I'll show it that way. I think that might be the way that most instructors are teaching it. So we've got to get y by itself, so I need to subtract the 2x over. And so then I'll be left with y is less than or equal to negative 2x plus 2. All right, so just solve it to get y by itself there. And then once it's by itself, now we can graph it on here. And since it's an equal to part, or has the equal to part to it, remember that it's going to be a solid line. But if it was just less than or greater than, then you would use a dotted line. Right? So we'll use a solid line on this. And remember, we can start here with our y-intercept. So I'm going to go up 2 places, put a point. And then from there, apply my slope, which is negative 2 over 1. So remember, it's rise over run, so I'll go down 2 and then to the right 1. And then I can do that again, go down 2 and to the right 1, which would put me here. And so I'll go ahead and kind of make this line, right, solid line, because it has the equal to part. But now, and this is the part that students oftentimes forget on the test, is to do the shading. It's not an equal sign, so we've got to do shading on one side of the line or the other. So you can do a test point, which is what some instructors tell students to do. So maybe we're going to pick the point 0, 0. All right, so that's going to be our test point, meaning we're going to put 0, 0 in place of our x and y here and see if we come out with a true statement or an untrue statement. Yeah. So is 0 less than 2? It is. Yep. So since it is, right, then it says this point is included, and so that means that this whole side here would be the part that's shaded, right? Because it's just one side or the other that will get shaded. But the other way to look at this that some students like and works well for their brain is they just look at this symbol and they're saying, okay, y has to be less than the line that we just drew. And so if we're thinking of the stuff that's less than, well, it's going to be the stuff, kind of in the negative area, or, like these are negatives, right? So we could think of it that way too. Either way, if you like doing the test point or thinking of it that way, good on you. Okay. Were there other questions that I missed? Let's see. I think I see number 17 off of the 3 and 4 review. Do you still want to do that one? We did one kind of similar to that on 26. Was it Jocelyn that said you wanted to do number 17? Okay, she said no. All right, we'll go focus on something else because we did one where we showed you how to find the slope. What about, looks like we have a request for number 55 on the Module 1 and 2 review. And I do suggest to you, take a look at your Module 1 and 2, like your Exam 1, and really go through that test again, because if they asked it once, it could definitely show up again. So you want to make sure anything that you missed on that first test you have down now, and that way you won't miss it again if that happens. Okay, so number 55 is talking about domain, and this is a good one to talk about. So when we're talking about domain, we're trying to figure out which x values will work for the function that is given. All right, so the function that's given for us this time is f of x equals 1 over x plus 4. Right. And it's interesting because we have this fraction here, right? And that looks a little bit different maybe than a lot of the functions that we've been seeing. And so we're trying to ask ourselves, well, what values for x wouldn't work? Because then that will give us a good idea of what would work. Well, one thing that we remember is that we can't divide by 0, right? Can't divide by 0. So I'm thinking in my head, what number would I put in place of x that would make the whole bottom 0? Right? That's what first thing I'm thinking to myself. You guys, anybody want to say what that is? So -4 is what Tina said, it looks like. All right, you see if we put -4 in place there, that's going to make the bottom go to 0. And if you're unsure, because sometimes you get some weird things on the bottom, you can always set that bottom equal to 0. All right, but this is what, and then solve for x. But this is what x cannot be. So don't get it confused with what we want it to be. X can be anything except for -4. And then it says, okay, now write that in interval notation as well. All right, so I'm just going to draw a little graph because sometimes that's helpful in thinking about interval notation. So if here's -4, and I'm saying it can't be this, so I have an open circle there, but it can be anything greater than or anything less than, right? And when I write interval notation, make sure you're remembering to always write it from smallest to biggest. So we're always going to start, furthest to the left as we can. So it looks like that's going out to -infinity, all right, and up to -4, but it doesn't include -4, right? So I need to put a parenthesis there on -4. And then I have to use this lovely union symbol too, all right? And then again, another parenthesis because it doesn't include -4. Everything except -4 will work. And so -4 to infinity. So that's how we'd write that in interval notation. Okay, and the only other one that you have to worry about here is kind of like on 56, right? If there was something with a square root, well, we can't have negatives inside the square root. So we always want to set that. I'll just do this one really quick. All right, so the stuff that's inside, we want to make sure that all of that stuff is positive. So that means that we're going to have it be greater than or equal to 0, right? Because it could be 0 also. So it could be 0 or any positive number. So we need it to be greater than or equal to. And so then if I solve this again for x, I'll get 2x is greater than or equal to 1, and then I'll divide by 2, so x has to be greater than or equal to 1/2. So again, if we graph it on a number line, just to be able to visualize what it's saying, all right, so here's 1/2, and it's equal to it, so I've got a filled in circle, and I want all the stuff bigger than it too. So for interval notation, how would we write that? Okay. One half? Yeah, it's going to clear out to infinity. And then remember, with the infinity or a negative infinity, we'll always use a parenthesis. Right? So all of the values 1/2 or bigger will work. Because if you try something that is less than this, right, then you're going to end up with a negative number, and that will make that statement false. And we can't take the square root of negative numbers. So that's why we have to make it greater than or equal to 0. Okay. Awesome. You guys are doing so good. Okay, let's see. So review 3 and 4. I see 43 through 45. I know that, yeah, some of these story problems are ones that people get really freaked out about for the test. So I definitely wanted to make sure we did some of these. So let's look at number 43 first. On that, let me switch over to the other review here. All right, so it says the admission fee at an amusement park is $10 for children and $15 for adults. If one evening 537 people attended and $6,265 was collected, how many children and how many adults were admitted? All right, so whenever I start off story problems, these word problems, I always like to assign my variables first. So this last line tells me what I'm trying to find. So those are my variables. So how many children and how many adult tickets. So you could use X and Y, or we could use C, right, for the children's tickets, and A for the adult tickets. All right, but if you like X and Y better, you can pick X and Y. All right, then the next thing that we need to look at is what we know about this information that it's giving us here. And so the first thing that it tells us, right, so it tells us how much each type of person had to pay to get in there. And but the part that we're looking at, so we're thinking, okay, I have, I don't know how many children's tickets there are, and I don't know how many adult tickets there are, but I know together, right, so I need to put it together by addition, they sold 537 tickets. So children tickets plus adult tickets would equal 537 tickets. All right, so there's my first equation. Now I've got to write my second equation, and this second equation is going to take into account the price of those tickets. So I know that the children tickets were $10, so I'm going to do this maybe in a different color here. So I'm going to have 10, right, times however many children's tickets were bought, plus 15 times however many adult tickets were bought. Right? And this is going to give me the amount of money, right? If I say 10 times however many children's tickets, 15 times however many adult tickets, that gives me the amount on that, and it tells me the total amount that was collected was $6,265. Okay? So now we have a choice to make, and I want you guys to respond on this to see what you want to do here. So would you like to solve this using substitution or elimination? Because we could do it either way. What are you doing? Substitution or elimination? Okay, Tina said, well, whatever is easiest. Well, on this one, I personally think that elimination is easiest because remember, with elimination, we're trying to add our variables together so that one of them eliminates. So if I look at say that I'm trying to, eliminate my C's, and you can pick, either one to eliminate first, but you've got to make a choice. So I'm going to say, okay, I'm going to eliminate C. So if I eliminate C, then that means I would need to multiply that whole top equation by -10 so that when I add it to this blue equation here, the C's will cancel out, right? So I'm going to put this underneath here now in red, distributing that through. So I'd have -10C minus 10A equals, and then 537 times 10 is 5,370. All right, so make sure and it should be negative. Sorry about that. All right, so make sure you multiply everything by -10. All right, then we can see here, all right, our C's are gone. We eliminated them. Awesome. That's what we were trying to do. And so then we're left with 5A equals, and then we just need to subtract these here. All right. Let's see here. Sorry, this pen is giving me troubles. Okay, so it looks like 895, and then we can divide that by 5. What do you come up with there? Okay, yep, and Tina said she came up with 197. Is that what everybody else came up with? All right, and so this is how many adult tickets, right? So it's not in money, it's the number of tickets. So I'm going to say 179 adult tickets were sold. All right, but we're not done because our question said how many adult tickets and how many children's tickets. All right, so we're almost there. I'm going to go back up to this top equation because that seems the easiest one to use to figure out what C is. So if I put 179 in place of A, or you can really just think, oh yeah, I'm really just subtracting that. I know together they have to be 537. So if I subtract the 179 off, okay, then, okay, can you mute your, it's okay. Okay, no worries. All right, and so then when we do that, what do we come up with? And that's what I came up with as well, 358 children's tickets. Okay. Okay, and make sure that you really clearly state which ones, like put your labels on things. I know most instructors will subtract off points if you're not putting down what's what, right? If you just put 179 and 358 and didn't say which one were adults, which one were children's, your instructor might deduct points off for that. So always give more information when in doubt, right? To make sure you don't miss any of those points. All right, are you finding this helpful so far? Are we going through the problems that you would like to? I'm trying to scroll back up here and see if I've missed some that you said you wanted to do. Okay, let's see. Number 56 in Module 1 and 2. Oh, wait a minute. Let's see. Oh, wait a minute. We're going to do a couple more story problems, so I think. Let's do a few more here because I know that this is where a lot of people get really stressed out about. Maybe let's do, we can just do maybe one more, and then if there's one that you specifically, another one you want to see, we can do. So let's do number 45. So how much of a 20% alcohol mixture and how much of a 65% alcohol mixture is needed to obtain 270 ounces of a 60% alcohol solution? All right, so on a problem like this, I like to make a little chart because it makes it easier for me to keep my information organized. Okay. So when I'm trying to write things down here, first thing that I think of, because some people are like, well, I'd make the chart, but I get lost in how to make it. Well, think about the things along the top are what you're mixing together. Okay, so I'm trying to mix a 20% with a 65% so that I get a 60% solution. All right, so that's kind of telling me, kind of my different, parts of what I have available, right? I'm going to put total above this because that's what we want in the end, is that 60% solution. And then over on this side, I always think, look at your example and think about what labels or units are being talked about. And that's what you're going to put on this side to help keep it organized. Well, it looks like we're talking about ounces. All right, 270 ounces. So I would put ounces since I see that as a label. And then I also see stuff about percents. So I'm going to put that in here. And then it also gives me information about the total. Okay. And now I'm just going to go in and fill in what I know in this chart. So when I'm thinking about ounces, what do I know about? Oh, I need to also decide what my variables are going to be. So I'm going to do that up here before we go any further. So I'm going to say my X, I'm going to call my 20% solution, and my Y, I'm going to call my 65% solution. Okay? And so we're trying to find the amount needed, right? So I don't know how many ounces of the 20% solution I need, so I'm just going to call it X. And I don't know how much of the 65% solution I need, and so that's going to be some other number, which I'll call Y, because I don't know what that is yet. But I know my total of 60%. Look over here, right? It says that I want 270 ounces of the 60% solution. So that means I know that together they need to add up to be 270. Okay? And so that's going to give me my first equation. All right, but let's keep going and filling in the rest of this. The next part on this percent line, I just change my percent so that they're decimals, because that's something that you need to make sure that you are doing when you're working with this. All right, and if that 20%, you could put 0.2 or 0.20. You don't need those zeros at the end, but if you like it better, you can use it there. And then our second equation is going to be written here in the total, and the way that we get that is by multiplying these two rows together. So I don't know how many ounces of the 20% solution I need. So I'm going to say 0.2 times X, and that's going to tell me the total amount of the 20% solution. And then 0.65 times Y. And then this is the part that students often forget about doing, is you still need to make sure that you multiply those two numbers together, because I want that 270 ounces to be a 60% solution. So I need to do 270 times 0.6, right? And I got 162 for that. Okay, is everybody with me so far? Is that making sense on there? Okay, Just want to make sure. Speak up if you have some questions on here. If you're like, oh, wait a minute, Becky, I don't see where you're getting that number from. It's totally confusing me. Let me know. I want to make sure I'm answering your questions here. All right, so my top equation, right, my x plus y equals 270. And my second equation is 0.2x plus 0.65y equals 162. All right, so now I have my two equations. Now I can either solve by substitution or by elimination. Since I'm dealing with these decimals here, I usually would rather do substitution for that. And so I'm just going to write over here, oops, let's see here. So if I solve this equation for x, to get x by itself so I can substitute it into the other equation, that means I need to subtract y over to the other side. So that means I'd have x equals 270 minus y. And so then I can take that 270 minus y and I'm going to put it in place of x here in the other equation. Okay. All right, so then when I do that, I get something that looks like this. 0.2 times 270 minus y. And use your calculator and figure it out alongside here with me. See if you're coming up with the same things. 0.65y equals 162. All right, so I need to use the distributive property, distribute that 0.2 through on that first. All right, which is going to give me 54 minus 0.2y plus 0.65. Whoops, make sure that decimal is showing up, 0.65y. All right, so now I need to combine those two y's together, right, so that I can make sure that I combine my like terms before I put those over to the other side. So I'm doing 0.65y minus 0.2y, which would give me 0.45y. All right, so I'm going to have 54, and it's going to be plus because this was my bigger number and it's positive, right? So plus 0.45y equals 162. Let me scroll this up just a little bit here so we're not running off the page. So now let's subtract the 54 over. I get 0.45y equals what? Okay. And then divide by, whoops, that's not a negative there, that's a decimal point. And do that. So divide by 0.45. And I got y is 240. All right. And so that is, again, remember, make sure that you're putting your labels with this. So 240 ounces, right, of, and my y was my 65% solution. So ounces of 65% solution. All right, so there's part of my answer. Now I need to go and figure out how much of the 20% solution I need. And so I need to solve for x. So I'll just go ahead and put that in there. So if I just have 270 minus the 240 that I just found, then x must be 30. And again, label it out, 30 ounces of the 20% solution. Right? And it makes sense that there would be a lot more of the 65% solution because we're trying to get a 60% solution. All right, so it seems to make just logical sense that there should be more of that. And always check that on these story problems, because sometimes I'll have students that end up with negative answers or something on this, and they keep it as their answer, and and you just got to ask yourself, could you have negative 240 ounces of a solution? Well, that doesn't make any sense, right? So just make sure that those answers are making sense, because you could have just made a small mistake somewhere that is making it negative when it shouldn't have been. So just watch that. Oh, let's see. Lindsay, did you figure out what happened on yours? Because somebody else probably had the same thing happen with them. Okay, what questions can I answer about this number 44? Oh, see, I know that decimal point. I almost did the same thing with my decimal point. She said I thought my decimal point was a negative and added it there. So, yep. Nope, I know. You can see mine on here too. That happens. So, yep, just kind of shows you, yep, we've got to be careful with writing things down in math for sure. So, okay, awesome. We're going through some great problems here. I think these are you're going to find these really helpful on the test that you take. All right, let's see. Let's go back to Module 1 and 2. A few questions there. Okay, we talked about 56, and then so 31A. Oh, on Module 3 and 4. Sorry, I read that wrong. I was like, that doesn't have a 31A. All right, let's get to the right one here. Okay, and I'll just tell you right now, they have never asked a question like this on the tests, because it's just too variable and there's too many different answers that people could come up with. And so but they have asked things like this before, like number 30. So if you don't mind, I think this one might be a better one to go through for us in getting ready for the test. Because remember how sometimes when you're dealing with raw data, you can get different answers, and so they won't ask something like that on the test, right? Do you want to see number 30 instead? Is that okay? All right, and this one has some trickiness to it too that I wanted to point out, because, so on number 30, right, it says, if the linear regression model for the data on tuition and mid-career salary is given by this function, f of x equals negative 0.94x plus 163. All right, so here's our function that models that. But notice it says, okay, x is our annual tuition. All right, so I'm going to write a few of these things in here. So this is tuition. All right, the x, and then it says the y, or the f of x, is the salary, right? So I'm just going to write that kind of here so we remember what's what. Okay, and then it says both of these are in thousands of dollars, and this little part gets overlooked a lot, and people mess up on this type of problem because of those few words right there. They forget to, we're not sure how to use that maybe sometimes. Okay, so it says, what is the average salary for a graduate of a university where the annual tuition is $30,000? Well, we said our tuition is, so we're going to put our tuition here in place of x, but it's already written in thousands of dollars, right? And so we really are going to have our x equal 30, not 30,000, right? Because that's just going to throw this off. We could change this to 163,000 instead, or we can change that 30,000 to just 30 because it's 30 in thousands, okay? So I'm going to put that in place here. So then we have f of x equals, and now the rest of this is really just putting it into your calculator, right? And then just making sure that the answer makes sense for what we're talking about there. All right, so when I put that into my calculator, all right, what do we come up with there? Should come up with 134.8. Okay, but this doesn't make sense as far as the answer goes, right? Because remember, this is supposed to be a salary. Are we saying that this person is only going to make $134 in a year? Like, that would be just such a crappy job if you only made that much per year. But remember, it said it's in thousands, right? So you've got to make that account for in your answer if it says something like that, okay, in thousands. So if in thousands means that I'd have 134,800, right? Need to put 2 more zeros there because really I'm moving that decimal point 3 places over. I'm multiplying it by 1,000, right? And that seems like a more reasonable salary. Right, 134,800. I sure wish I had that salary. That would be awesome. Hopefully you guys will get that salary one day. Or even more. Would be awesome. Okay, questions on that? Do you see what I mean about the 30? How you had to change that 30,000 to 30 to put it in. Right? But only if it says something weird like in thousands, right? Something crazy like that. All right, what other ones shall we look at? Oh, somebody said they wanted to do a distance equals rate times time problem, and I missed that. So let's go back to go back to those story problems there at the bottom, and let's do number 46 also. All right, because if that's one that you've been struggling with, these distance equals rate times time, I want to make sure I can help clarify anything on there. All right. So on this type of problem, I also like to set up a little chart to organize my information. And a couple of things that I know here, right? So an airplane travels 360 miles in 2 hours with the wind. The return trip against the wind takes 3 hours. What are the wind speed and the speed of the airplane in still air? So the two things that I'm trying to find, right? So I'm going to call W my wind speed and P my plane speed, or speed of the plane, right, in still air. Right, and so the whole thing about this, in still air or not, is because remember, if you're going with the wind, that wind is actually pushing the plane faster than it's actually going. And when you're going against the wind, it's actually slowing you down from what the plane could go. I don't know if you've ever taken a trip anywhere and noticed that, you travel the same amount of miles, but, one way is a lot longer than the other way. And that's usually because of that wind speed. Okay, so we know stuff about with the wind. So let me just write a little chart here. So with the wind, and they also call that, so they call a headwind and a tailwind. Sometimes they use those words. So this would be a tailwind if it's with the wind, right? And then we also have information when it's against the wind, or it would be a headwind, the wind coming towards you, right? Okay, so then what do we know here? Well, we know we got to break this down to distance, rate, and time. And those are the three things that they give us information about and things that we need to fill in here. So I know that we've got, okay, so our distance is 360 miles. And it says a return trip, right? So that means we're going 360 miles both ways, right? So whether we're going there or back, we'll go 360 miles. But when we're going with the wind, right, it takes us 2 hours. And when we're going against the wind, it takes us 3 hours. Okay. Now, this is the tricky part right here with the rate, okay? But I want to break down a couple of things for you here to hopefully make it a little bit easier to understand. So when I'm talking about rate, okay, rate is made up of two things, right? It's made up of the wind speed and it's made up of the plane speed. So I'm just going to write down something like this. So the plane speed plus or minus, right, whether we're going with the wind or whether we're going against the wind, is going to determine whether we're adding or subtracting off the wind speed. Right. So on our first one, so our rate, right, that we're looking at in this top equation, we're going with the wind. So we're going to have our plane speed plus our wind speed. Right? It's moving us faster. So we're going to use the plus. And against the wind, it's slowing us down. So that's going to be our P minus W. Okay. So now we have our two equations here. Remember, we have distance equals rate times time. That is the formula that we're using. So let me just write those two equations down here. So I've got 360 equals, and let me write that. I like it writing my 2 here instead. Right? It doesn't matter with multiplication, whether I write it as 2 times P plus W or P plus W times 2. It just works better with my brain having it in the front there. And then my other equation is 3 times P minus W. Okay. Now you could go through, some people, sometimes students, the first inclination is to multiply and distribute that 2 through and distribute the 3 through on the other one. And you can do that, but there's a faster way that you can do this. Notice that, this is connected by multiplication. So in order to undo that multiplication, I could divide that whole side by 2, and then that means I need to divide the other side by 2. All right, so those 2's divide out on that side, and I'm left with 180 equals P plus W. And then here, same thing, right? Instead of distributing that 3, I'm just going to divide that whole side by 3 and the other side by 3. And so when I do that, I'm going to write it underneath here. 360 divided by 3, all right, is 120 equals P minus W. And now we're set up in an awesome position to do some elimination, because if I add these together right now, I see, oh yeah, my W's already eliminate. So that's super awesome. So that's what I'm going to do. So if I add these two equations together, right, I'm going to get 300 equals 2P. And then I need to divide both sides by 2. So I came up with, right, my plane speed is 150 miles per hour. Right, is my plane speed. Now I want you to think about something for a second. If you came up with your wind speed being more than your plane speed, should you be worried? I wouldn't want to be on that plane. Would you want to be on that plane? I don't think you'd be in the air still, because if that wind speed was so strong, then going like that. That would be terrifying. So yeah, definitely don't want to do that. So, all right, so we know that 150 miles is the plane speed. How would we find the wind speed? Anybody have an idea? Yeah, Lindsay says just take 180 minus that 150, all right, and that's going to give us our wind speed. So the 180 minus 150 gives us 30, so 30 miles per hour is the wind speed. Okay, and again, if you came up with negatives on either of those things, again, you should be worried, right? Just recheck your arithmetic and make sure that those things, you didn't make like a negative mistake somewhere or something like that, or add when you should have subtracted, or subtracted when you should have added, right? Okay, let's see. 39 on the same review. Oh, this is a good one to look at. Oh, I'm glad you asked this one. Okay, and something like this has been known to show up on the test, so this would be a good one to look at. Sometimes, right, the fractions in this freak people out like crazy. So let's work on this one. So I'm going to first just look at that equation with the fractions, okay? And let's take a look at this first, because when I have fractions in equations like this, I like to kill the denominators. Just get rid of them. I don't want to have to work with fractions if I don't have to. And since it's an equation, not an expression, I don't have to work with these. And so I can multiply the whole equation by the LCM, right? And on this one, these both happen to be the same, but if one was 7 and one was 14 or something like that, then we'd have to multiply the whole thing by 14. But they're both 7, so our LCM is 7. So that means I'm going to take each part and multiply each part by 7, or 7 over 1. When you're dealing with those fractions, might be a little bit easier way to think of it. So I can see that I'm going to simplify this first term here, right? My 7s divide out. Look at that. Now there's no more denominator. And all I'm left with there is a 2x. All right? And then on this next term, those 7s again divide out, leaving me with no denominator, which is totally awesome. And then I have plus 2y equals my 2 times 7, which is 14. Okay, so now, and I did that work first because I noticed that that one had fractions, but the other one didn't. All right, so I'm going to write the other equation now underneath here, and this is what we're going to be using to solve now. All right, so I've got my 2x plus 2y equals 14, and my 12x minus 2y equals 14. Okay, awesome. I know, I hate fractions, so we got rid of them, right? Look at how much easier this question looks, right? Just getting rid of those fractions. But do you have questions up to this point? How I got to that point? How I got rid of those fractions? Okay, so go through and try and solve it along here with me, right? See if you get the same thing. So I came out with x equals 2. All right, so part of my answer here, if I'm writing it as an ordered pair, all right, my x is first, then my y, so it's 2 comma something. And so now I just need to put that x into either of those equations. You could put it back up into the equation with the fractions if you don't like yourself very much, but I would suggest putting it into one of these two equations. You'll be much happier, right? So let's go ahead. I'm just going to put it into that top one because it looks easier to me. All right, so that means I would have 2 times 2 plus 2y equals 14. So I get 4 plus 2y equals 14. and then I'll subtract 4 over. 2y equals 10. Divide by 2, so y equals 5. All right, and then remember, you can always check these answers as well. If you want to, this is what you came up for y, this is what you came up with for x, you can put those back into each of those different equations and make sure they come out to be true solutions. Anytime in math when it says solve, unless it's with an inequality, you can always check your answers. And you can still do a sort of check with the inequalities as well. You can check individual points and see if they work. But when it's an equation, why not just do that? If you have time, you might want to save it until the end to make sure that you have time to work through it, but it's a good thing to just try and do there. Okay, awesome. Lindsay said that's what she got. Yay! Did everybody else get that? Wasn't that so much better getting rid of those fractions? Oh my word. Like, why work with fractions if you don't have to? Some people like working with fractions. Good on them, right? I've had some students tell me that they like working with fractions more than decimals, and I'm like, what? So maybe we should just eliminate them from the test. Awesome. Probably not going to happen, but that is nice positive thinking there. Okay, any others that you can think of? Just looking through the review myself again to see if there's anything there. Any types of problems we haven't went through yet. Remember that I will be posting this, I guess students that aren't in my classes though, I don't know if you're going to be able to get access to it. I guess you could search for my name, Becky Connolly. It's going to be just on my YouTube channel. So that's where I will post this after, so that if you weren't able to make the whole thing but you wanted to look through and see what kind of questions we went through, then we definitely, then you can go back and do those for sure. All right, so number 19 on module 3 and 4, Yami? Okay, we actually talked about that one already earlier on, so why don't you look for my link when I share that with the class, and you can go back through and look at that, right? You can just kind of scroll through really quick on the assignment and you'll see it there. Okay, but let's go and do, it looks like 41 was another one requested. I also think 24 would be a good one to look at. So let's do both of those. Okay, so 41, another lovely story problem, right? Everybody's favorite. Okay, you are choosing between two different cell phone plans. The first plan charges a rate of 22 cents per minute. The second one charges a monthly fee of $35 plus 8 cents per minute. How many minutes would you have to use in a month in order for the second plan to be preferable? All right, so we've got to make two equations here, right, to be able to do this. Remember, with our equations, right, we're writing them in the form of y equals mx plus b, right? And we talked about how m is the slope, but remember, slope is the same thing as rate of change. That's another word that you should have heard this last chapter, right? So slope and rate of change are interchangeable terminology. So if it says find rate of change, use the slope formula, right? That's the same thing. And then you also need to know this y-intercept, okay, which is also called the start amount. All right, meaning what would it be if, if they didn't charge anything more than like their flat fee? Is kind of what I mean by that start amount. All right, so if we're looking at these two plans, all right, so the first plan, all right, So if we're keeping this equation in mind here, it charges a rate, now look at that rate, right, of 22 cents per minute. So that is a rate, which is the same thing as rate of change, right? It's a rate. So 22 cents per minute, that's going to be, so we're going to have y equals, in place of my m, or my rate of change, I'll have 0.22, right, 22 cents per minute, times my x, right, and then plus whatever starting rate they give us. Well, that one doesn't have a flat fee. They just say, we're just going to charge more per minute, and that's it. So it's kind of like there's a plus 0 here at the end, but we don't really need to put that in, right? But you could put it down if that helps you to think through it, right? But then on the second plan, right, we know that they're going to charge a monthly fee of $35, so that's your start amount. If you don't even, have, any minutes at all, like you lost your phone or whatever, they're still going to charge you that $35 no matter what. But then they'll charge you 8 cents per minute on top of that. So again, that 8 cents per minute is my rate. So 0.08x plus my start amount, right? They're going to charge me $35 no matter what, right? And so now I want to use this, these two equations to figure out when is it going to be better, right, for the second plan on this. So let's go ahead. We already have y by itself here, right, and we have y by itself here. So really, and this sometimes confuses students because they're like, how do I do this? But you're really just taking this 0.22x and you're putting it in place of y there. You're just setting the two equations equal to each other, if you want to think of it that way. So 0.22x, right, went in place of my y, equals 0.08x plus 35. And now let's get the x's on one side. And then our whole numbers on the other side. All right, so what do I get there when I subtract those? And be really careful with your negatives and stuff on these. This one is positive, but it just reminded me when I was looking at this that so many students make negative mistakes on these types of problems, which I don't want to have you do. All right, so I've got 35 on the right hand side, 0.14 on the other side. So let's divide by 0.14. And that gives me, so x is 250. Well, what in the world does that mean? What is it that I just found? Because that's usually what people get confused about. Somebody tell me, what does that 250 represent? Okay, so minutes before it's worth it. All right, so at 250 minutes, right, it's saying they're going to be the same exact price, right? So you'd have to, have 250 minutes or 51 minutes, right, to make it so that it would be a better deal for you on that case. All right, does that make sense? So it is the minutes, and sometimes people go, what is it that I just found there? I'm not sure. All right. So we could just write our answer as like more than 250 minutes. All right. And then it would be worth it. Okay. Awesome one to look at there. Let me go back up and I want to just look at one here. Let's look at this number 24 also. All right, this kind of goes back to this whole idea of rate of change again. Sometimes when students see something like this, they get kind of freaked out because they're like, it says find the rate of change, and then they're like, well, wait a minute, what am I supposed to find again, right? It's just telling you to find the slope, right, between these 2 points, but we need to write down that information maybe in point form, okay? All right, so let's look at 24. We could do either 23 or 24, but let's just do 24. And so on this, right, and they give you a couple of hints here that you need to pay attention to also. So in 2009, there were 879 jobs in a small town. Then in 2015, there were 423 jobs in that same town. Find the rate of change in jobs per year. Okay, I'm going to write that down here because this is important. You need to know whether you're putting the jobs on top or the years on top, right? We want jobs per year. Okay. And so we want to figure out exactly what that rate of change is. Well, it might be helpful to write down our information as ordered pairs also on this. All right. And if we wrote those down as ordered pairs, we'd have in 2009, there were 879 jobs, right? Because remember, when we're dealing with the rate of change, it's our change in y over our change in x, right? So our years need to be our x, and our jobs need to be our y. Okay, just to clarify that. And then 2015, there were 423 jobs. All right, so then you're just using the slope formula, right? Because that's the same thing as rate of change. So I'm going to have my y1, x1, y1, and my x2, y2. So 423 minus 879 over 2015 minus 2009. And then notice that you're going to get a negative number here, and that is actually just fine. That's telling us that it's decreasing, right? So 456 over 6. All right, so keep that negative there. Make sure you don't just, let it disappear there. It is negative. And then that's going to simplify. If you divide that out, that's going to be negative 76. Okay? But again, it wants to, put it into words. What does this negative 76 mean? Right? Yeah, jobs lost per year. Okay? So when I write it down, I'm going to say, 76 jobs lost each year from 2009 to 2015. Right. That is sad. Wonder if it's like Detroit or something. Man, can't believe how that went downhill so fast. Okay. Yeah, so somebody was asking me about if we'll be able to view this whole video. I'm trying to think where I could post that, though, for those of you that are not in my classes that are attending today. I'll send it to the instructors that that sent emails to their students, and then they can send out that link to you. That might be the easiest way. Okay. I mean, you could also email me. Let me just write my email on here. And if you want to just email me individually, I'd be more than happy to just send that to you. So becky.connolly@slcc.edu. Okay. Because, yeah, I know some of you are probably getting a little burnt out from so much math that we've done so far tonight, but I appreciate you hanging in here, and and I hope you're getting a lot out of it, because that's the point of all of this. Okay, was there another question that somebody asked that I missed? Let me go back up. Number number 19. Nope, I already answered that one. Okay. You're welcome, Lindsay. Just look back maybe on a few things. We haven't done much off of the Module 1 and 2. And the test is, just so you know, it's more heavily weighted with the Module 3 and 4 objectives. But there are definitely, still, plenty of 1 and 2 that you want to make sure that you go back and review over any of those that you might need there. Let's solve one of these problems. Let's go back to these fractions because, like I said, students just freak out with fractions, and I don't want you to be freaking out on the test on this. So let's look at either 9 or 10 on the Objective 1 and 2 review. Let me pull that back up here. Okay. So 9 and 10, right? They have these fractions in them. And so let's do number 9. We can do both of them if you want. Let me get through with number 9, and then if you're like, yeah, let's do number 10 also, just to make sure we can do them both. All right, so this one, 1/4 y minus 3 equals 1/7 y. So just like I said on that other one that we did some, killed the denominators in, we first need to decide what our LCM is, because that's what we're going to use to kill our denominators. And if you can't figure out what the LCM is, you could always multiply the two numbers together, and that will always give you a number that you can use. In this case, when we multiply those together, we get 28, and it is also the LCM, so great. So that means we'll take and multiply, remember, each individual part, including this number in the middle. This is what everybody seems to forget to do, because they think, oh, it doesn't have a fraction, so I don't need to multiply it by it. But you do. Every single part needs to be multiplied by 28, okay? Or 28 over 1, if that's easier for you to think of with those fractions. All right, and again, we're just taking each term and simplifying it. So 4 divides into 28 7 times, and then 7 times 1y gives us 7y. All right, and now I need to do the 28 times 3. What do we get there? Let's see. 4, 6, 84. And then on our last one here, last term, 7 divides into 28 4 times. So 4 times 1 times y is 4y. All right, and look at that. Look how much better that looks. There's no fractions in it. You look at that and you go, I can totally solve that one, right? Where maybe at the beginning you were like, I don't know, maybe I'll just keep this problem till last because I don't want to work with those fractions. Right? But you don't need to do that, because look at this. This makes it so much better. Okay, so now we just need to get y's on the same side. So I'm going to subtract my 7y over here. And I have negative 84, don't forget about that negative, equals negative 3y. And let's divide both sides by negative 3. And what do we come up with? $28, yes. Okay, so y equals 28. And a lot of times on these type of problems, you do end up with a fraction for your answer, so don't freak out if you end up with a fractional answer. However, if you end up with a fractional answer on any of the systems of equations ones, that rarely happens, right? When you're working with systems of equations. I mean, in real life it would happen, but I'm just saying they rarely put questions on the test that come out to be fractions. So I would just say if you do come up with a fraction on solving those systems of equations, I would just check back through your work and make sure you didn't make a little mistake somewhere, right? Or you could even plug those fractions in and try and, see if you come out with a correct statement or not there. Okay. All right, so, yeah, somebody said maybe 11 or 12 as well. right? Do you have a preference of which one you want to do? Or if we want to do 10 also, or how are you guys doing? Okay, 12? Okay, let's do 12. Make sure you're speaking up. You can either use your mic or use the chat box. Right. Okay, so number 12. This one, again, we're solving. But this time, we have what's called a proportion. And not just any kind of, not just like fractions that we have up here, because notice up here we didn't have one fraction equal to another fraction, but that's what we have in number 12. So when you have one fraction equal to another fraction, then that means it's a proportion. And your instructors may have told you when there is a proportion, right, you can multiply the diagonals, right? So this one is saying 7 parentheses x plus 3. Make sure you remember that parenthesis, right? Because we're going to have to end up distributing that through. And then we can also do the same thing with our other diagonal. We're going to multiply those guys together, right? And then we set them equal to each other. So 8 parentheses x minus 9. All right, and again, look at that. No fractions that we have to deal with right now by doing this proportion, by multiplying the diagonals and setting them equal to each other. All right, when we distribute that through, we get 7x plus 21 equals 8x minus 72. All right, so let's get our x's on one side and whole numbers on the other. I'm moving my x's this way just so that they're positive. I get a positive 1x there. And then I'm going to add my 72 over to this side, right? And so then that will give me 93. All right, so x equals 93. Okay, so somebody said it's only with proportions that or is it only with proportions that we can multiply diagonally? And that is true, right? It has to be one fraction equal to another fraction. If we had, something like this, and then out here it was x plus 3 over 8 plus 5, like that, it's no longer a proportion. And so we wouldn't be able to do that. We'd actually have to do the other method that I said with multiplying each part by the LCM. Okay, so that was a good question. Right? Only works when we have proportions. Okay. All right, we just have a couple of minutes left here, about 8 more minutes. So speak up. If there's any other questions, you're thinking, oh yeah, I wanted to look at one like that. Does everybody remember how to do those type of problems where it's, a student has these 3 different scores on his first test, and then they want to get an average of another score, and so what do they need to get on their 4th test score? Do you remember how to do those, or do you want me to work through one like that? Okay, let's do it. All right, so this is number 40 on this one. And this one is an example of, I think this is one of the, I think you had a question like this on your first exam. And so like I said, make sure you go back through your past exam and really, have down really well those questions because they definitely could show up again. Okay, so a student has scores of 80, 68, and 75 on his first 3 tests. He needs an average of 73 to earn a C in the class. What is the minimum score that the student needs on the 4th test to ensure a C? All right, so we know that we're trying to find the average of his 4 test scores, but the problem is we don't know what he has on his 4th test score, right? That's what we're trying to determine. And so when we're finding an average, right, we add all the test scores up together, and then we divide it all by 4, because once we know this, there will be 4 tests, right? And then we need it to be, so it says he needs at least a 73, right? So we can say like greater than or equal to 73, right? Because I'm sure he won't be too upset if he gets above a 73, but he needs at least that. Okay, so to solve this, there's a couple of different places where we can start. Oftentimes students want to add those first 3 test scores together, and I think that's a great place to start. So let's do that. So what is 80 plus 68 plus 75? So I got 223, whoops, plus x over 4. All right, just added those 3 together, but I still had that plus x over 4 is greater than or equal to 73. All right, now this is sometimes where things fall apart for students, so make sure you're paying close attention here. Again, we have this denominator, right? And we want to get rid of that denominator so we don't have to deal with it. And so you can kind of think of it in 2 different ways. You're thinking, okay, I'm dividing by 4, so to undo that, I need a times by 4. Or it's the same thing as thinking of I'm multiplying both sides by that LCM again, right? And so with that, these 4's divide out on that side, so you don't have a fraction anymore. So that's super awesome. So now we have 223 plus x has to be greater than or equal to 73 times 4, which is 292. And then to get x by itself, let's just subtract that 223 over. All right, so x needs to be greater than or equal to 69. So he needs a score of 69 or better on that next test. Hopefully he gets above that, right? I'm sure he'd be much happier if he got higher than that. And I know you guys are all going to get higher than that on this next test, right? Got to think positive. Okay. Is there one last one you want to look through? And remember, these reviews are just, I mean, your instructors should have sent them to you. I know sometimes instructors forget until later, but if they didn't send you a review, I just send them an email and just say, hey, could I get the Module 3 and 4 review? Because those are good. All right, if you guys, 39. Okay, I was just going to say, let's do one of these type of problems like these and or statements, because those little words and or make a big difference. Okay, let me look at that, and then if we want to go look at 39, we can also do that. Okay, but 42, this tends to be a favorite type of question that seems to show up on tests. All right, so we're going to solve graph and write the answer in interval notation. Now let me caution you that usually students forget to write the interval notation part of this, and so they miss points when they really knew what to do. They just left that part off, so just watch those directions really carefully. Okay, and I'm going to just box this word or, because that word, even though it's really little, means a lot. Okay, let's first start by solving those 2 inequalities down. So if I add 2 over, all right, I get 3x is less than -9, and then I'll divide by 3. Remember, if this were a -3, right, if we're dividing by a negative, we would flip that inequality sign. That is something you need to make sure you keep in mind here. It's not going to happen on either of these 2, but just remember that. So x is less than -3, right? It doesn't matter that this top number is negative. It's the number we're dividing by. Okay, if that one's negative, that is going to flip our inequality. All right, so when we solve this one, we have 4x is greater than or equal to negative 4. Divide by 4. All right, so x is greater than or equal to negative 1. All right, so don't stop there, right? This is the important thing to remember. You're not done. It says graph it, write it in interval notation, all right? And remember, this is a number line, so the numbers as they're going further to the left are getting smaller, and as they're going further to the right, they're getting bigger, so make sure that you're doing that, okay? And treating that as a number line. So at negative 3, I notice that I have a less than symbol. It doesn't have the equal to part, so that means I am going to have an open circle there, right? Where on the negative 1, it does have the equal to part, so I'm going to have a closed in circle, all right? And now this is where this word or becomes super important. Remember that the word or is used for union, and the word and is for intersection. All right, and then some people are like, well, yeah, that's clear as mud now. All right, so union basically means everywhere the graph is. Okay, all right, so everything. And the intersection is just the overlap of the two graphs. Okay. So on this one, right, I want the stuff that's less than negative 3, so I know it's going to be to the left of negative 3, right, but not including it. And then I also want the stuff that's greater than or equal to negative 1, so it is at 1 and everything to the right. Okay, so those, I've graphed my two graphs on there. Now I need to decide, okay, it's an or statement, so I want everywhere the graph is appearing. So that means all the stuff less than negative 3, all the stuff bigger than negative 1. So my interval notation, right, remember we write this from left to right, from smallest to biggest, so it's going to go clear out to negative infinity, to negative 3, but it doesn't include negative 3, so we'll put a parenthesis. Then union, negative 1, it includes negative 1, so bracket, negative 1, and clear out to infinity. So there is your interval notation. Okay, but I want you to just do a little suppose for a moment. Okay, what if? So what if this was an and statement instead? How would that change? So this is our graph still, right? But if it said and instead of or, what would my answer be? Anybody have an idea? So if this was an and statement instead of an or. So remember, the and statement means intersection. It's saying where is the overlap? Yeah, it would be does not exist, right? There's no solution. There is nowhere on this graph that it overlaps. So, so see how that changes drastically what your answer is going to be. So that little word means a lot, right? Since it's or, it's this. If it was and, then it would be the DNE, right? Does not exist or no solution, however that is, okay? And let's see, somebody asked if our reviews are counted towards our final grade, right? And that depends on your instructor. So you would need to ask your individual instructor. In my class, it isn't because I figure, I mean, you should do the reviews to do well on the tests. If you do the reviews, you're going to do better on the tests, and the tests are a huge part of your grade. So, so that's just for my class, but yeah, my students tend to do better if they're doing the reviews. All right. Okay, well, we are out of time here, unless there's any more. I mean, I'm willing to do that last one there for you with number 39. Would you like me to go through that one? Yeah? Okay. I had somebody say they wanted to, so let's go through that one, and then we'll call it quits tonight, because those of you that have been here since the beginning are probably, your brains are probably getting a little bit tired. But remember, I'll post that link and email me if you're not in my class, and I will send that YouTube link to you so you could go back if you weren't able to join us for the whole time. Okay? All right, so Sarah's goal is to find a job that provides an income of at least $65,000 a year, right? And that word at least, right? So she wants to make 65,000 or more, right? At least. She's not going to be sad if she makes less than it, but she wants something greater than or equal to 65,000. A company offers her a paying job with a base salary of 17,000 a year, and plus a 14%, or sorry, a 4%, 14% would be awesome, 4% commission of her sales. Determine the amount of total sales she needs to have, right? So how much does she need to sell in order to get that $65,000 salary, basically? Okay, and we're going to kind of go back to that same thing that we talked about with the y equals mx plus b, all right? So when we're talking about this, right, we know, okay, this base salary, so even if she doesn't sell a single thing, she's still going to make $17,000 a year. And that's the B part. So I'm going to put that in here. All right, so she's going to make that no matter what. But on top of that, right, she can add more to it by making some commission on what she sells. So we know that she is going to get 4% of whatever she sells. All right, so this X represents, right, her total sales. So if she gets, however much she sells, she gets 4% of that, and then we'll add that amount to 17,000, and she wants to be over 65,000, or at least to that point. Okay. All right, I'm going to get rid of this so it's a little bit easier to solve here. All right, but usually this is the hardest part, is setting it up. Think about what we talked about before, right? This is a rate, this is our start amount, right? And so the rate always goes with our X, right? Because that's the thing that's changing, right? Depending on how much she sells, she's going to make more money. All right, so we'll subtract that 17,000 over. All right, and so we have 0.04 X equals, what do we get here? 65,000 minus, you guys come up with 48,000, all right, but we're not done. We still need to divide by 0.04. All right, and this is going to give us a huge number. Wow. All right, so this is money, remember, that we're talking about. So she needs to sell $1,200,000 worth of stuff in order to make that sell. So, wow, that's a lot to sell, but maybe she's selling some high-ticket items, right? And she'll get there. So, like real estate, that they make good commission. So, it could be something like that. Okay, so that would be your answer there. So she'd have to sell at least, well, I guess I should have really kept this as a greater than or equal to symbol all the way down, right? So she needs to sell at least $1,200,000. Okay. All right. Well, it's been so good. Thank you for all your interaction and stuff on this. I really appreciate it. That's going to help you do the best that you can on the test. And email me a little bit later. It takes a little while for it to get all uploaded and stuff to YouTube when something is 2 hours long. So I'll need at least it might take me an hour or two to get it up, or look for it tomorrow. Okay. But I hope you guys have a great night and good luck on the test. You're going to do awesome.